Okay, thank you, Mark. Hi, my name is Paek. I'm a researcher at EPFL Space Center. The topic I'd like to briefly touch upon today is the optimization and executive aspects or challenges in on-orbit servicing. First, sorry that there's nothing original about my own research, but I'm always interested and hope to work on this topic sooner or later. So first, we will take a couple of real examples before we jump into theories behind. Half a year ago, the space community witnessed the first commercially available, successful on-orbit servicing mission called the mission extension vehicle. This mission was basically a space talk or space booster, more accurately, that provided station keeping for geostationary satellite that ran out of its own fuel. As you can see in the small box, the sequence of docking, servicing, and undocking is repeatable. The MEV is different from refueling, what you might have thought of, because it is strictly used for steering, pointing, and relocating another spacecraft that is running out of propellant. After the first repositioning, the MEV will continue servicing the first initial target, which is Intelsat 901, until 2025. After that, more nearby satellites might be serviced. The first refueling in space actually happened earlier in 2007 during the Orbital Express mission. This was a US government-led non-commercial mission which demonstrated propellant refueling as well as hardware exchanges. In the figure on the left, NextSat, a tiny satellite, is a target, and the larger satellite with a robotic arm is in charge of on-orbit servicing. Back to the mission extension vehicle example. The target satellite could not accommodate this kind of refueling or hardware upgrade, so the servicer simply pushed it for repositioning. It would not be efficient to use this servicer for only one target, especially in the era of emerging mega-scale constellations. Servicing the target or visiting certain locations in general, has been an active area of research in computer science and operations research. Visiting multiple places efficiently may have different meanings depending on context or applications. But distance minimization would be the simplest objective here. Graphically speaking, this traveling salesman problem, or TSP, is equivalent to connecting all bunch of dots just once, as shown in this cartoon, using as small amount of ink as possible. In addition to sales and delivery applications, the TSP problem has numerous other applications in electric circuit design, robot controls, biology, and space logistics, which we are talking about today. There are a number of variants for this basic traveling salesman problem. For example, okay, I'll skip this. Profits and time windows may be considered on top of physical distances. If we think of on-orbit servicing as a business case, contracts may be written and signed such that whoever pays more cost is serviced earlier. As for kinetics or dynamics, well, this term originally used to mean moving targets in ship supplying examples on the sea, refueled by an oil tanker. But in space, not only the target satellites move themselves, but the cost of traversing among these satellites could continually change as time goes by due to the orbital mechanics. There are other factors to consider in terms of configuration that generalizes this traveling salesman problem further. Multiple salespersons or servicing satellites are required for sure in order to deal with multiple targets. Especially here, we are talking about thousands of satellites launched in constellations every year in the following years. And there have been no such technological demonstration, but the orbital propellant depot will come into reality soon. So using one or more of them will add to the mission value. But at the same time, the problem complexity will even increase. Lastly, rather than servicing one satellite continuously until its end of life, it is more practical to make visits, targeting a group of satellites, allowing for multiple visits, which is more flexible concept of operations. These questions were faced by shipping service providers from a long time ago. Deliverers have been utilizing various means of transportation, first on foot, but nowadays using vehicles. So the generalized form is now called the vehicle routing problem. This can be stated as what is the optimal set of routes for a fleet of vehicles to traverse in order to deliver to a given set of customers. For on-orbit servicing, we may rename it as a space vehicle routing problem. According to this news article published recently, an orbital propellant depot will soon become a reality, it seems. The planned launch is just 3 months away, and the propellant tanker satellite is named after Tenzing, a famous Sherpa, a mountaineer in the Himalayas. So let's go back to the traveling salesman problem and take a look at some mathematics to understand the challenges. Minimizing the total distance can be written as double sigmas on your left side as objective function. X ij is on-off coefficient and dij is the distance. The subjective conditions on the right make sure that each city has exactly one inbound trip and one outbound trip, which can be modified, of course. The possible solutions are exact algorithms or heuristic algorithms. Exact algorithm might be the most accurate, but it's very time-consuming and expensive in terms of computing power. You can see some examples on the left-handed box, and you can see even though the CPU has increased exponentially over time, it still takes a lot of time to solve larger-sized problems. On the right side, you see some heuristics methods. Anti-colony optimization is most popular, where the agents traverse and mark or increase the importance of more efficient paths. At the bottom, you see nearest neighbor method, and you see there are different solutions depending on how you implement the method or where you start in the map. So far I talked to you about optimizational algorithm challenges, and now there are even more challenging things in terms of operations, which is safety. Because satellite can be illuminated unfavorably, we need to use multiple sensors to fuse their information, such as laser or infrared wavelengths, in addition to visible wavelengths. As ClearSpace presentation already told you, the hazard of creating even more debris is problematic. Also, When a spacecraft servicer is docked with the target, its cross-section area increases, so it becomes more vulnerable to contingencies such as space debris. Market size profitability is a problem, and in addition to that, contingencies should be covered financially. So my suggestion would be to reduce complexity by subdividing this large problem into smaller subproblems. For example, we can only take a look at more vulnerable, a small number of satellites, which will decrease the burden, computation burdens, and operation burdens. So thank you for listening to my short review, and I'll be happy to answer your questions at the end of this session.